analysis, but we're also going to analyze not only the data we gathered, but we're going to analyze other data. And this part of the whole thing is pictures, graphs, and charts. Because pictures, they say, are worth 1,000 words, and indeed they are. Right now I'm speechless because I can't find my projector to turn it on. My clicker.
Is it?
Ah, yeah. Thank you. Where is the clicker? Yeah. Come on, wake up. Well, it may have been laying there because the battery's dead enough that it doesn't want to take it. I'm not right. There it goes. Okay, there we go. So we're going to be talking about Chapter 2. Hopefully you've got your Chapter 2 notes in front of you. As we get started, I'm trying to make a seating chart for the room. What I'm going to do is I'm going to pass this around. Those of you that are in the back of the room are going to be on this top row. Those of you that are here in the front are going to be on this bottom row. And since the way that I will look at the class is from the instructor's station, when you get it, this is the front row, this is the back row, okay? Just sign at whatever seat or print your name on whatever seat that you're sitting in. That'll help me check the class roll just simply by looking around the room. So we're going to start out in Chapter 2 by actually getting some notes, and then we're going to work some examples. Hopefully you've got your notes in front of you. First thing I'm going to do is explain to you what a frequency distribution is. I really wish they would do something with that thing. Come on, Paul. There is no happy medium. I guess we're just going to be stuck with a black band across the top. Okay. When we're working with a large data set, it's helpful to organize and summarize your data by making a table called a frequency distribution. Frequency just means counts. How many times do you see something? The frequency distribution helps us understand the nature of how the data relates to each other, basically. It also shows how the data set is partitioned among several categories or classes of data by listing out the categories and then listing the number of data values that you have, the number of pieces of information that you collected that goes in each one of the categories. The best way to think of this is to actually look at some data and talk about what we're going to do with it. So here we've got some data. They have measured, apparently in beats per minute, pulse rates of a bunch of men and women, 40 of each to be accurate. And if you look at that set of data, that's actually a set of what we call bivariate data because there's two different groupings within the data. If we look at that data, can you really tell me anything about people's pulse beats just by staring at those numbers? Is it easy to give me any information about that? Even though I might be interested in predicting, are men's pulse rates different from women's? Or what is the average pulse rate for women? What is the average pulse rate for men? Can you even think about giving me that just by looking at those numbers? I hope nobody says yes, because that makes you way smarter than me. Because, I just don't see it. I don't see how to do that. Okay? Because my mind, like yours, isn't geared to look at a big bunch of numbers on a piece of paper and come to any conclusions about those numbers. The only way I can start coming to conclusions is to kind of sort those numbers out and organize them and see how many are in a certain area and how many are high and how many are low. Well, that's what frequency distributions do. So in this case, what I did was I took that big pot of data, you can think about that as being a basket of index cards that has male or female on one side and a pulse rate number on the other side. And I take this big basket and I say, well, all right, I only want to take out the female pulse rate. So I dig through and I find all the men, lay them on the other side. And then I leave the female pulse rates in the basket, and I have to have a set of boxes to sort them into. And my first box is going to sort in all the women who had pulse rates between 60 and 69. And then my second box, I'm going to toss in the index cards that are the pulse rates of the women whose pulse rates were between 70 and 79. So I'm going to have a total of 1, 2, 3, 4, 5, 6, 7 boxes that I'm throwing index cards in. And then when I get finished, I'm going to count how many index cards, each of which represents a person's pulse rate, that are in that box. Those boxes are called class intervals. Okay? And the data values themselves, the women's pulse rates, are what I'm counting. And when I count those, in the first box, I found that I had 12 pulse rates that were between 60 and 69. And I had 14 that were between 70 and 79, and so forth. And in fact, my box that I labeled 110 to 119 doesn't have any index cards in it because nobody had a pulse rate in that particular range. Now, once I've got this table, I can start to see some information about my pulse rates. I could begin to answer some questions. Is it common that a woman has a pulse rate over 100? Oh, these are the ones that are over 100. There's only 2 women out of that whole group that had pulse rates over 100. One of them had a pulse rate over 120, but still that wasn't very many. Okay? In fact, I can see that most women have pulse rates in the first 2 categories, somewhere between 60 and 79. I can see that because I've now summarized my data in a way that lets me begin to analyze it. That's why we want to be able to make a frequency distribution. We need to get some terminology first. Lower class limits, and this is on the first page of your notes. It is not the very first sentence, but it is on the first page, about midway down. Lower class limits are the first number of each class interval. Okay? It's the smallest number that can belong in that class. So if I had a pulse rate that was 42, I don't have a class to put it in because that's smaller than all of my lower class limits. Upper class limits, with the same idea, is the largest number that can belong to each class. So for example, if I had a pulse rate of 90, I can't put it in this class, I have to put it in the next one. Because the largest number that goes in that class is an 89. If I had a pulse rate of 130, it doesn't fit in any of my boxes because it's outside of the highest class limit that I have. Class midpoints are the middle of every class interval. My first class here contains the numbers 60 through 69. But the middle number of 60 through 69 is 64.5. I can find that easily enough because if I go 60, 69, 61, 68, 62, 67, 63, 66, 64, 65, in between 64 and 65 is 64 and a half. And notice there was a total of 10 numbers in that first class. 60, 61, 62, 63, 64, 65, 66, 67, 68, 69. 10 total numbers. I know you look at that and think, oh, there's 9. No, there's actually 10. Okay? And the 10 actually tells me that I've got 10 here, and the next 10, 60 plus 10 is 70, the next 10 go in the next box. Okay? So you can find your midpoint of any interval, including class intervals, by adding the two endpoints of the intervals, the lower endpoint and the upper endpoint. Just add those together. 60 plus 69 is 129, and then divide by 2. And you'll have the class midpoint. Class width, and this is right above where we talk about the limits. Class width is the difference between two consecutive lower class limits or two consecutive upper class limits. Or this one refers to it as lower class boundaries. We're going to talk about what boundaries are. The class boundaries are actually the dividing line between this upper class limit and the next lower class limit. So in this case, my boundary would be the midpoint between 70 and 69, and it would be 69 and a half. That would be the class boundary. Okay? The class width here is 10. And that's because there are 10 numbers that go in each interval. Be sure you realize how you're using that 10 to build your table. If you start out and your minimum pulse rate is 60, you add 10 to that pulse rate to get the beginning of the second group. And then you add 10 to that one to get the beginning of your next group, and 10 to that one to get the beginning of your next group, and so forth. So going down the table, there's a constant difference of 10. The reason we're going to construct frequency distributions, once again, is because you can summarize a large data set, and ours was not a particularly large data set. It was only a total of 80 pieces of data. Large data sets can be 1,500 to 2,500 pieces of data, and we really don't want to look at those on a piece of paper and try to make sense of them. We can analyze the nature of the data, how it compares to one another, how one group compares to another group, what's normal for that data, what do we expect to see in that data, how spread out are those values from each other, they're all relatively close to a middle set of numbers, or they spread out all over the spectrum. And it gives us a basis to construct some important graphs. And the graph we're going to construct today by the end of class is called a histogram. That's probably where we're going to wind up with this class lesson. So we're going to begin by actually doing an example. So in your notes, start off at your first page. I'm going to go through with you and make sure that you filled in your correct answers in your notes. But you should fill these out as you're able to go. In fact, the best thing to do is when you have these class notes is to go ahead and print them out before class. And then open up the PowerPoint that's in that same folder with those notes for each one of the chapters. And try to go through the slides of the PowerPoint and fill in your notes as you go. Now when you come to the examples, you don't have to do the examples because likely they're not going to be on the PowerPoint. You're just trying to fill in definitions and words. And then we'll do the examples mostly in class. But since this is our kind of first one that you're filling in like this, I'm going to walk you through it a little bit. So at the top of this page, how do we find class width? You find class width by taking the maximum value and from that you subtract the minimum value. And then you divide that by the number of classes. How many classes do you want? And this is key. And this is the only time you need to worry about doing this. Everybody in here probably already knows how to round numbers. If it's 13.12, you round that to 13.1 or you round it to 13. If it's 13.5, you round that up to 14. Okay, if we were rounding that way. That all works in most everything else, but there's a special rule for rounding class widths. And I'm going to demonstrate to you why we have that rule. So when we go through this, you're going to understand why you are always going to round a class width up. You always round it up. 13.1 rounds up to 14. 13.25 rounds up to 14. You round up to the same number of decimals as the data. So for example, when we were looking at the data values that were pulse rates, our pulse rates were all integers. They were all whole numbers. There was no decimal places. There were 0 decimal places. So in the case of the pulse rates, we rounded our class width up to a whole number, like the data, which meant we rounded up to 10. Okay? So for example, assuming that we have integer value data, what you think of as whole numbers, we're going to do these examples. And it's okay to use a calculator for these because I don't divide all that well in my head anymore either. So what we're going to do is we're going to use this calculator. And the first one we have, it says that our maximum data value was 150 and the minimum data value was 45. So we take our maximum data, which is 150, and we subtract the minimum data, which is 45, and we get 105. And it says we want 8 classes, so we're going to divide 105 by 8. And get 13.125. But because we always round up, we're going to round that up to, since we're talking whole numbers, 14. Which is very counter to what you normally would have done. And I'm going to show you why it's necessary that we do that. If I were trying to make 6 classes, instead of 8, I would have divided by 6. And gotten 17.5. And 17.5, because I'm going to the next whole number, would be rounding to 18. If I wanted 7 classes, I would divide instead then by 7. And that one comes out to be a whole number, but you still round up. So the class width would be 16. Even though it came out even, you still round up. okay? Now, I know that doesn't make any sense to you why you would do that. So I'm going to show you why you have to do that, okay? So you've already got these notes. They're in the PowerPoint. Let's look at our example. And for the moment, I don't need the calculator, so I'm going to put it down. And I have here this set of data. It says the data that we have in that box over here, those data values represent the weight in pounds of wild bears between the ages of 8 months and 177 months. We want to make a frequency distribution of that table, and we want it to consist of 6 classes. So it's important to notice that we're looking for 6 classes. Then we have to also look at the data, and we need to determine the class width by taking the maximum weight of a bear in our group minus the minimum weight of the bears in our group, and we're going to divide it by the class width, by the number of classes. So our calculations are going to require that we find the littlest bear in the group and we find the biggest bear in the group, subtract those two, and divide by 6. Now, you can look through the table and find those values easily because that's not a really big set of numbers. So I can look and I can tell that the smallest number in this table is 26. And I can look a little harder and see that the largest value is 436. So that's not really terribly hard to figure out. You just have to look at all the numbers and figure out the biggest and the smallest. So my largest one is 436. My smallest one is 26. And my number of classes is 6. So that's a difference of 410. Which I'm going to divide by 6 and get 68.3. And that's going to round up to a class width of 69. My class width is 69. I'll round 68.3 up to 69. So remember that. The first lower class limit is always, unless there's a good reason otherwise, we generally let it be the minimum data value. So our first lower class limit is going to be that 26-pound bear. Okay? Now I want everybody to put their pencil down. I don't want you to write this down. I want you to just watch. Okay? Let's suppose I'm some enterprising statistics student that's trying to get ahead, and I didn't read the part about rounding up. Or I forgot the teacher said round up. So I'll look at 68.3 and say, oh, that rounds to 68. Because normally that's what we think. 68.3 rounds down to 68, right? This is what I would do. I would say, okay, my class width is 68. In order to get my next class limit, I'll take my 26 plus 68. Notice I'm working with a pencil because I'm going to make a mistake. I'm gonna take 26 plus 68, and I get 94. And then I take 94 plus 68, and I get 162. Let's see if I've got a pencil with a little bit more lead in it. Might have to be hitting the sharpener. So my next one's 162. And then I'm going to add 28. I'm sorry, 68. And I get 230. And I get 298. And then I add another 68. And I get 366. And so far everything looks good, right? Now remember, you're not writing these down. You're just watching. So I've got all these lower class limits, but I need the upper class limits as well. So if I get the upper class limit, if this first class is not going to contain 94, what's the biggest number it can contain? Okay, and that's a good point. But we'll say the nearest whole number, because these are all whole numbers in our data, would be 93, although it really would be 93.9999999, because the bear weighs 90, oh, excuse me, hate aborted sneezes. A bear might weigh 93.9999999 and still not weigh 94 pounds and have to go to the next class, okay? My next one is going to be the same interval. I'm going to go up 68. So it would be 161. And then I'll add 68 again. And get 229. And add 68 again. And get 297. And add 68 again, and get 365. And I'm just trucking right along now, and I'm very happy because this all seems like it's so easy. I'm just adding 68. And I get my last upper class limit. And exactly. My biggest bear weighs 436 pounds. My biggest bear does not fit in the highest class interval I have for my data. I can't make another class because then I have more classes than I was told to make. I can't throw him out because he's part of the data set. So at this point, when you do this, and actually you're probably not going to realize it when you get this far. You're probably, if you're just focusing on the process, solely on the process, and not looking at the end, you're going to get there and say, okay, good, I've got my classes made, let's start counting bears. And you're going to count all the bears, you're going to write numbers in here for how many are in each one of these intervals, you're going to get to the last one, and you're going to put how many bears falls in that one, and then you're going to look at it and say, but I have a bear left over. Miss Flint, what do? I have a bear left over. I don't have a place to put that bear's weight. And I'm going to look at you and smile and say, start over. Erase your whole table and start over. Because if you don't have a place to put your last bear, you didn't build your table right. Okay? So then you've got to be frustrated and spending twice the amount of time you need to on a problem because you got to do it twice. So let's do it right the first time. We don't add 68. What we add is 69. So now I'm going to go through and do it correctly, and now you can pick up your pencil and follow along.
So what's wrong with not using the 68 this one?
It would work, But I don't really want to have to sort to the tenth of a place if I can sort just the whole numbers. So yes, it would work. It wouldn't be wrong. But it's easier, since our data values are all whole numbers, just to break our classes into whole numbers, okay? And even if I was rounding the 68.33333, I still have to round that up to 68.4. It still won't work. I'll wind up at the exact same place. I'll still have a problem. Because if you don't round up, your last class won't contain your largest piece of data. You have to round up, okay? So let's do it correctly. We're going to use the correct class width of 69, not 68. So our first class width should have been 95. And our second one should have been 164. And my next one should have been 233. And if you're noticing what I'm writing over the top of, the difference in what I did the first time and the correct answer, the difference in those two answers is getting bigger as I go down that table, and that's why it is such a bad mistake to do what I did. So then my next one, 233 plus 69, is 302, whereas before I had 298. And then 302 plus 69 is 371. So even though here I was only off by 1, now I'm off by 2, now I'm off by 3, now I'm off by 4, and now I'm off by 5. My correct answer is 5 more than what I originally thought it was. That's why it's so important that you round up correctly to begin with. And now the largest number that's going to go in this interval is going to be 94, not 93. And if I add 69, then I get 163.
Okay, so where did you get the 94 again?
If this is the first value that goes into the second group, what's the last value that could have gone into the one before it? 94, okay? So the 94 plus 69 is 163. And since I'm just adding 9 as I go down, I'll go ahead and add them all. So 232 is my next one. 232 plus 69 is 301. 301 plus 69 is 370. And 370 plus 69 is 439. Will my biggest bear fit in the last class?
Yes.
He will now. Okay? But you have to do the right class width. This is very, very important. If you miss that, you're going to miss the whole table. Be sure to remember to round your class width up. Never down, always up. Okay? Now all I have to do is I have to go through those bears and count. How many are there between 26 and 94? How many are there from 95 to 163? And we could go through and just count them by going through the table and marking them off as we can. Nothing really wrong with that, except for the fact that I am really probably the laziest person you know. Okay? I really don't like doing anything if I can make somebody or something else do it for me. So what I'm going to do instead is I'm going to use my calculator because it will help me do all of this very, very quickly. In fact, if I had showed you to do this in the beginning, it would have shown me the max and the min without me having to hunt and pick through that table. So here's what we're going to do. I want you to get a TI calculator in front of you, either on the computer or the one that you brought with you, one or the other. Your two favorite buttons on this calculator are going to be the button that says Stat, which is right there, and VARS, which is right here. And the second function of both that and that calculator key, which is, here's your second button. If you hit second Stat, that's the name of all your lists. And second VARS is going to be the names of all the distributions we use in chapter 4 and 5. Your calculator does all of the formulas for you. You do not have to memorize formulas. People that memorize formulas need to memorize the phone book. That's, the phone book's probably more useful than the formulas. You can always look up a formula. You don't need to memorize a formula. So we're going to go to the Stat button. How many people know what Excel is? Used Excel a little bit. Okay, well your calculator has a little piece of Excel built into it. Something like Excel. It has a spreadsheet. You get to its spreadsheet by hitting the Stat button and choosing Edit. Trying to get it up high enough I can actually turn it off and on. Okay.
Get the TI calculator on the
This will be the easiest way because it's on your desktop. You don't want to do that. I'll make it last time. You shut down and delete. Right here.
computer. Here it is open.
So there is a calculator on the desktop, and if it doesn't pop up and let you use it, when you click on it, let me know and I'll look at it and see what's wrong with it. But there is one on the desktop. However, don't get too excited. You don't get to use the computer on test day. You still have to have your handheld calculator. If this is the only math class you're taking, think about going over to the books, or I'm sorry, not to the bookstore, but think about going over to the business office and renting one for $25. Because they cost $125. You may as well rent one for $25. Now,
Probably still find these for like $90 at least.
you might, but if you, still, if you only need it one semester, $25 is cheaper than 90, that's some gas money. Okay, so when you open your calculator, does anybody's calculator have numbers already in your lists? Okay, go to the list where the numbers are and start hitting the delete button and watch them disappear.
Or you can just click on
All right, yes, you can. You can. And I am going to show you that too. There is a quicker way to clear out your data. But I don't want to show you right now because we'll have to go down a little side path that will eventually, you won't remember it when you need to remember it. What's going to happen if you try to use the clear function instead? By sitting on the list, you'll delete your list rather than clear the data. And I have gotten many panic texts in the middle of the night. This one, I broke my calculator. It doesn't have any lists anymore. They're all gone. What am I going to do? And unless I'm just particularly crabby or the phone's already off, I'll text back and say, Stat, number 5, enter. You're good. But right now, you don't need to go down that path. Let's just use delete until I show you the quick way to do it. Okay, so just delete them. If you have to delete 300 times, hit delete 300 times. You can't mess up. I want you to enter those numbers into list 1. And it doesn't matter that there's 5 different columns. All of those numbers are going in one list because that's all one set of data. when you get to the bottom, underneath the last data entry, it should say L1 and then in parentheses 26. And that's because there are 25 pieces of data. Okay, your last entry was at the 25th spot in that list. I want you to go back up through that data by arrowing up and looking at every number and matching it to the table. Because if you mistyped any one of them, your answers are not going to be correct. And you're not going to know why they're not correct. You're going to assume they are because, hey, it was the calculator. Calculator did the math. Yes, it did with the numbers you gave it. Be sure the numbers you give it are correct. So when you're sure that you've got your data entered and it's all correct, look up, and I'm going to show you the slickest way there is to be able to order your data. But I'm willing to wait a couple of seconds on people to double check, because if you put a bad number in, it's going to come back and haunt you. You always edit your data. You spend less time making mistakes if you spend more time editing. Okay, we all happy with our data? Okay, hit the stat button again. This time choose option 2. Sort A means sort ascending. Start at the littlest one, end with the biggest one. Sort D means sort descending. Start with the biggest, end with the littlest. Ascending is going to be easier because our table is in ascending order. So we're going to sort ascending, and then you have to tell it which list. The way you tell it, list 1 is second, and the number 1 key, and then close your parentheses. And then you hit enter. And immediately it says, okay, I'm done. It took me longer to type the data in than it did for it to sort the numbers out and put them in numerical order. Now, if you go back and look at list 1, it goes from the lowest number to the highest. So if I had gone ahead and entered my data in before I ever started, I wouldn't have had to look for the 26 and the 436. I would have said, okay, the littlest one's 26, and the biggest one's 436. Okay? That's not really why we want to do this, although that is kind of nice. When they're in numerical order, it is far easier than using that table to just count up how many there are by counting the numbers in the list on your calculator. So I'm looking for all the numbers that fall between 26 up through and including 94, but not 95. So from here I just count. 1, 2, 3, 4, 5. My next number's too big, so I have 5 in that first group. And then I start again. And I have to stop when I see anything bigger than 163. So there's 1, 2, 3, 4, 5, 6. Oop. I'm done. I had 6 numbers. And then I start again, and I'm counting all the numbers that go from 164 to 232. So when I see anything bigger than 232, again, I stop. So I go 1, 2, 3, 4, whoops, getting close, 5, 6, 7, 8, 9. Oh, that one's over 300, so I had 9 total. I think I miscounted, so I'm gonna go back and look again. I think I may have missed my end point. And that's the good thing about having it this way, because I don't have to go back and erase all the marks and start over again. I just go back to the calculator and say, okay, what's the first number that went in the 164 group? That one. So I have 1, 2, 3, 4, 5, 6, 7, and I'm done. So now I can start counting again, trying to put them in the 233 group, and I have to stop when I get to 302 or bigger. So there's 1, 2, ooh, I only had 1. It just went right away to bigger than. So I have 1 here. So then my next group starts with 302 and goes to 370. I have 1, 2, 3, 4, and I'm done. And all the rest should go in the last group. 1, 2. Okay? So what helps you count? You can use Excel to do the same thing. It would be easy to sort the data in an Excel list and then go down and just count them. And at some point when we're starting to work with Excel, I'll show you how to do that. But the one thing I want to do is I want to make sure I didn't miscount. How many, get rid of my calculator for a second. How many bears did we have in our original sample? Does anybody remember? 25. Then what should these numbers add up to? 25. Now you can use the calculator, or you can do it by hand. 5 plus 6 is 11, 11 plus 7 is 18, 19, 23, 24, 25. That symbol that I just made there, looks like a backwards 3, is called a summation symbol. It means add them up. The sum of the frequencies was 25, which was the same as the number of bears. Yes?
A good spot to discuss relative frequency.
Yes, but we're not going to go there yet.
Well, I mean,
I understand, but we're going to practice with this a little bit first. So yes, we are at a good place to talk about relative frequency, but all they asked us to do was make a frequency table. So for the idea we've got here, I need to stop and say, does everybody understand, or does somebody have a question? If I gave you another example to do, for example, the Old Faithful worksheet, could you do this process on that worksheet? Because that's what we're doing. Okay? So at this point, let's go back to the PowerPoint and move on if nobody has any questions. So yes, indeed, we are now ready to talk about relative frequency. If you're talking about relative frequency, what you're talking about is the number in each category and what proportion of the whole entire group is in that category. Okay, if you remember, we had 40 pulse rates for the females in the example that we're doing in the PowerPoint. We had a total of 40 female pulse rates. If I go back a couple slides, I see that I had 12 of those 40 in the first category. So when I take 12 and divide it by 40, what do I get? If you have a calculator in front of you, you tell me. 12 divided by 40 is 0.3. How do I change 0.3 into a percentage? Twice. Move the decimal 2 places, which direction? To the right. So the decimal's in front of the 3, 2 places to the right. Says I have to add a 0 after the 3, and that's 30%. Okay? Same thing for 35%. My frequency was 14. 14 divided by 40 comes out to be 0.35. And that's 35%. The same way all the way down. I didn't mention it before, but it's important to point out to you that even though there were no pulse rates in the 110 to 119 category, you can't skip that category. For one thing, you never know if you took another sample and tried to put them in the same table, you might have some in that category. For two things, if I was trying to compare the women's pulse rates to the men's pulse rates, I would want to use the same class intervals and compare the counts in each class. Just because there were no women that had that pulse rate doesn't mean that there were no men that would have that pulse rate. So I need that category. Not only that, but it preserves the spacing. You don't ever leave out a category just because you don't have any data values that fall into it. Then we can also talk about something called cumulative frequency. Okay? Cumulative frequency means that for your first category, which is all of the people that had pulse rates, or all the women that had pulse rates less than 70, that was only 12 because there were 12 in the first category. But all of the women who had pulse rates less than 80, that was everybody in the 60 to 69 category and everybody in the 70 to 79 category. So I would add those two together. 12 plus 14 is 26. If I move into the next category, everybody that is in these first three categories together has a pulse rate that's less than 90. That's the 12 in category 1, the 14 in category 2, and the 11 in category 3. So I add the 26 I already have here, I need to add 11 more and get 37. And then when I move to the next category, I'll add one more and get 38. My next category gives me one more, so that's 39. My next category doesn't add anything to it, so it stays at 39. But then my last category only has one piece of data in it, and 1 plus the 39 gives me all 40 of my women. So all 40 of the women had pulse rates less than 130. Okay? The sum of your cumulative frequencies is also, not the sum of them, but the last value of your cumulative frequency table is the number that was in your sample to start with, because you hit all the sample at that point. So now we're going to do another example. So we're going to practice what we've already done with a different data set. And then we're going to add our two new ideas to that. So I want you to go with me through this and help me figure these out to make sure everybody has the right things. This is our new set of data. We want to make a frequency distribution, which is down here, that has 5 classes. 1, 2, 3, 4, 5. Not 6 classes, not 4 classes, 5 classes. Your first step is going to be to load your data into your calculator just to make your life easier. Now, you have choices here. You can type right over the top of the numbers in list 1. I have no problem if that's what you want to do. You can save those numbers in list 1 so you can go back later when you're looking at your notes and look back at how you got those numbers if you want to. That's fine too. If you want to do that, you still need a list, so you could go over to list 2 and type your new data into list 2. That's what I'm going to do, in case we need to come back to list 1 for some reason. So into list 2, I'm going to type these bear weights, and this time there are more of them. There are 36. I'm sorry, and these are not weights, these are body lengths of 36 bears. So enter those into list 2. And just as you did before, go back through and make sure you didn't make any mistakes.
I think did that thing you mentioned earlier about accidentally clearing it all.
Let's see. Okay, get your stat button. Edit. Okay, so it's still there. That's all right. Okay, so when you're sure your data is correct, what do we do next? You hit your stat button. You choose option 2, sort ascending. You tell it which list, and in my case I'm using list 2, so that's second L2. Enter, and it says it's done. So I can go back and look at my list 2. And now they're in numerical order, smallest to largest. So my minimum data value is 36. My maximum bear length is 75. Everybody find that okay? Okay, class width. Now we're ready to make class width. 75 minus 36. Five classes means I divide by 5. So that's 39 divided by 5, which gives me exactly 7.8. And I round up to 8 because those bear lengths are also in whole numbers. So I round to a whole number. Okay? So my class width will be 8. My shortest, littlest bear, probably that little 8-month-old up there, is 36. So that is my first lower class limit. To that class limit, I'm going to add 8, and then add 8 again, and then add 8 again, and then add 8 again to get the rest of my class limits. 36 plus 8 is 44.
45 plus 8 is
Excuse me?
45 plus 8 is 53.
But where did you get 45? 44.
Oh, it's 44 because of the
No, you keep adding 8. So it's 44 plus 8 plus 8 plus 8. Remember, you keep adding 8 every time. So 44 plus 8 is 52. 52 plus 8 is 60, and 60 plus 8 is 68. So these are what are called your lower class limits. Collectively, those are your lower class limits. Okay? Then I have to determine, well then, okay, what is my upper class limit for the first class? Well, my first class, there's 2 ways you can actually do this. You know it has to be less than 44, and the whole number that's less than 44 is 43. And if you wonder why 8 is what you add, here's what I want you to pay attention to. That first class contains the numbers 36, 37, 38, 39, 40, 41, 42, 43. 8 numbers. That's what your class width is. That's why you don't take 36 plus 8 to get this. You start with this being value number 1, and you count up till you get 8 values. And the easiest way to do that is just to add 8 to your starting value. So then now that I have my first upper class limit, which we call UCLs, I can simply take that 43 and add 8 to it, and then keep on adding 8 and get all the rest. And notice that all I had to do was take the answer plus 8 and just keep hitting enter, and every time I hit enter it adds 8 more. So there's all my upper class limits. And collectively, that's what gives me my class intervals. This is my class interval numbers from 36 to 43. So those are my intervals. And now to find the class midpoints, I'm going to take the lower class limit of the first class, which is 36. I'm going to add to the upper class limit, which is 43. And divide that by 2 to get the midpoint. So 36 plus 43 divided by 2 is 39.5. And then since I know I'm going plus 8, 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 all the way down the table, I'm gonna do the same thing here. I'm gonna add 8 until I get the rest of them. So 47.5, 55.5, 63.5, and 71.5. So your midpoint is your lower class limit plus your upper class limit divided by 2. Okay?
You keep doing 6 on your calculator, and it's only 5.
Yeah, but I mean, all I'm doing is adding 8, and then I can copy down and stop copying when I've got all that I need. I don't need the extra one. But I just keep hitting in until I get what I know I need. Okay? Now, we've got the class intervals, we've figured out the midpoints, now we've got to start counting. So in order to count, we're going to go back to the stat menu and look at list 2, because that's where our data is, and we need the numbers that go from 36 up through 43. So if I see a number that's 44 or more, that I've got to stop counting. So there's 1, 2, 3, 4, and I stop counting. And then I begin counting again, and I'm going to go up to, but not including 52. 1, 2, 3. Can't count the next one. Then my next group is 52 to 59. 1, 2, 3, 4, 5, 6, 7, and I have to stop. And then I'm going to go the 60 through the 67, so I can't include 68. So I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's it. So all the rest of them belong in my last class. 1, 2, 3, 4, 5, 6, 7, 8. And notice that the 75 just barely made it. And once again, if I add my frequencies up, what I should get is 30 pieces of data, right? 4 plus 3 is 7, 7 plus 7 is 14, 14 plus 9 is 23. Ooh,
3 plus 8 is 31.
yeah. Maybe I need to go check my arithmetic, so let me not do it in my head.
44 to 51.
Okay, let me go back up and recount 44 through 51. And see, if I weren't adding up my frequencies, you know, I'm a statistics student. I didn't add up my frequencies. I should have. I turned this in, what's going to happen? You're going to get a bad grade. If it's me, I get a bad grade because I should have checked to make sure that my frequencies totaled up to my sample size. I didn't make a mistake counting. Because I got lots of help to count. So I need 44, which starts right there. 44 and 4, yeah, you're right, that's only 2. I should have only had 2. So now, 4 plus 2 is 6, 6 plus 7 is 13, 13 plus 9 is 22, and 22 plus 8 is in fact 30. And I had 30 bears.
cumulative frequency if you want to.
Well, we can go ahead and do cumulative at this point, because when we do cumulative, the way that we're gonna do cumulative is we start out with the first class. Cumulative frequency is just 4, because we've only got one class. But for the second one, we have 4 plus 2. That's gonna be 6. You get the calculator out of the way. And then adding the 7 from the next group, or simply 7, not 6. So adding my 7 from the next group, that'll be 6 plus 7, and that's 13. And then I add 9 to the previous group. 13 plus 9 more gives me 22. And 8 more after 22 gives me 30. And this 30 in that last cell should match the total of the frequencies. Okay? So now we've got one more thing to do. Relative frequency. I'm going to be dividing by 30. My frequency, which is 4, divided by my sum of my frequencies, which is 30. Did I get verification for that? 0.075? Okay, what's 4 divided by 30? Okay, check your math.
Sorry, I divided by 4.
We're good.
So it's 0.13 repeating, and as a percentage, that's 13.3%. Do not round to whole percents. Keep a decimal place. So then I have 2 over 30, and then 7 over 30, and then 9 over 30, and then 8 over 30. And I'll get the decimals and change to percentages on those.
9 over 30. Because 3 times 10
yes.
is 30. So we do
Right.
30.
This actually would be 30% because it comes out to be 0.3. And you're going to report that as 30.0% because you want that 1/10%, even though it is 0. So 2 over 30 is 0.6666. Which is going to be 6.7%. You want to round that one up because it's 6.6 repeating percent, so that's going to be 6.7. 0.23 repeating, which is 23.3%. And this will be 0.26 repeating, which is 26.7%. And fractions, decimals, or percentages are all correct as relative frequency, unless you're told a specific one. Then you can use whichever one you want. But if I tell you a specific one, you need to know how to take the fraction, change it into a decimal, and once you've got the decimal, if I've asked you for a percent, you need to know how to convert it to a percent.
Then adding those up, we get 100%.
You should add up. That's right, 13.3 plus 6.7 plus 23.3 plus 30 plus 26.7 should add up to 100%.
Alright, why did you round up to 6.7, but you didn't round up to it? Cause that is really ignorant, you didn't round up to 3 or the.
Okay, because the 26.6, the 6 is gonna repeat, The next decimal is more than 5, so you round up on the last decimal place. Okay? You didn't do it up here on 7 over 30 because that's 23.33333. So the next decimal place is not more than 5, so you just throw away the rest of the decimal and keep the 3. Okay? So we have 13.3 plus 6.7 plus 23.3 plus 30 plus 26.7, and we add it up and it says it's 100%. Now I will tell you, because of round off error, depending on, right now in this one we rounded up and down the same number of times, so it came out even. It is possible when you're adding up your percentages that you could come up with 100.1%, or you could come up with 99.9%. That's just round off error, and that's not a problem. Just go ahead and call it 100%. You're good. Okay? But if you get like 109%, you messed up. You need to go back and check your math. So does anybody have any questions on that exercise?
You want us to put the 100% at the bottom of relative?
Yeah, that's why that blank's there, is that if you add up your relative frequency, you should get 100%. Or 1. If you just added up the fractions, it would come up to be 1. Okay?
Can we fill the blanks at the top of the page?
Let's fill in the ones that I've already told you how to do first, and then come to the class boundaries last. Cumulative frequency. The cumulative frequency for a class is the total of the frequencies for that and all, not other, lower or previous classes. Because it's the ones that are less than that one, the ones that are behind that one. Okay? Relative frequency is the proportion. We'll use that word a lot in statistics. The proportion of values in each class. To find the relative frequencies, divide the frequency of each class by the total number of data values. Okay? Class midpoints are the values in the middle of each class. To find the class midpoints, add the lower and upper limits of a class and then divide by 2. Okay? Class boundaries, and this looks like it's asking for 3 separate words, and there's a lot of different ways I could explain this. Class boundaries are the imaginary dividing line between 2 classes. Okay? They're created by the class limits, but they're created by adjacent class limits. So it's the midpoint It's the midpoint of an upper class limit and the next lower class limit. Okay? And in order for you to understand what those are, we are going to list them, but we're going to go back and actually look, not at this table we just did because it's gotten kind of full, but I'm going to go back to the first example we did, and we're going to talk about what the class boundaries would have been. So looking back at example 1, we're going to find class boundaries. And class boundaries have an upper and a lower, just like class limits do. The first one I'm going to show you how to calculate is not the lower class boundary, because we're going to kind of back our way into that one. The class boundary between these two classes is the midpoint between 95 and 94. This is the upper class boundary of the first class and the lower class boundary of the next class.
94.5.
Yes, I think you're right. So we're going to take 94 and 95 added together and divide by 2, because that's how you find midpoints. But on this one, you probably don't even need to do the math, because what do you know is halfway between 94 and 95? 94.5. Okay? And if I wanted to find this one, it would be 163.5, right? And if I want to find this one, it will be 232.5. And if I want this one, it's 301.5. And this one is 370.5. But now we've got to back up and figure out, okay, what is the first one? What is the lower class boundary? Well, what we're doing is we're extending this one up by 0.5 and this one down by 0.5. So if I extend 26 down by 0.5, what number am I at? 25.5. So you don't actually calculate that first lower class boundary, you kind of think about what it naturally has to be. Class boundaries are always halfway between two numbers. And if those two numbers are whole numbers, that means it's going to be a 0.5. So my first class boundaries is 25.5 to 94.5. My second set of class boundaries, and this actually makes it easy, this class begins at 94.5 and goes up to 163.5. So this upper class boundary is dead up against itself to be the next lower class boundary. And this probably won't make much sense to you until I show you a histogram. So we're going to be looking at a histogram in just a second. So to finish these out, here's my first set of class boundaries. There's my second set. I'm going to repeat this one. There's my next set. Then this one repeats itself. Excuse me. And this one repeats itself. And then I need one more. And that's going to be exactly 1/2 a unit higher than the last class boundary. Okay? So to make it a little bit clearer, because I know mine are a little bit jogged up there, for this class goes $25.5 to $94.5. The next one goes $94.5 to $163.5. This one goes from 163.5 to 232.5. The next one goes from 232.5 to 301.5. Then this one goes from 301.5 to 370.5. This one starts at 370.5 and goes to 439.5. This one is also repeated to go with this one. Okay? And I'm going to point out something sort of interesting to you. What is 94.5 minus 25.5? What's the class width? 69. 25.5 plus 69 is 94.5, plus 69 is 163.5, plus 69 is 232.5, plus 69 is 301.5, plus 69 is 370.5. That 69 is preserved going all the way down that table, whether you're looking at lower class limits, upper class limits, lower class boundaries, or upper class boundaries, which means that all you have to do is find one class boundary and then use it to construct the rest of them. Okay? Now, what is a lower class boundary? We don't want to memorize some kind of a formula for how you find it. What actually is it? It is the dividing line right here between the first class interval and the second class interval. On a histogram, it is where the bars for the first class interval and the second class interval actually come together. That's what makes that a histogram. In a histogram, your bars must come together. In a bar chart, they're separate. There's always a gap between them. A histogram is for numerical or quantitative data. Numbers have a tendency to be right up against one another. 31, the next obvious number is 32, but there's a whole bunch of little decimal values in between 31 and 32. So there's numbers in between there, and for that reason, the bars actually touch. And because of rounding, anything that is, for example, 69.5 or lower goes into first class. If it's lower than 69.5, because we just make that convention. But if it's 69.5 and higher, then we round up into the next class. Okay, so your boundaries are the dividing line between the bars of your histogram. That's really what they are. And one of the things that we need to be able to do is to make a histogram. So this is a histogram of the pulse rates. Notice that the first bar represents the category of pulse rates that went from 60 to 69, which means the boundaries of that bar is 59.5 to 69.5. The midpoint of that bar is 64.5. We could have labeled that by its midpoint as well. The key idea is that that bar is 12 units tall. The height of the bar gives you the number of values that's in that first class. So the height of the next bar is up to 14 because the next category has 14 pieces of data in it. And one of the things that we're going to look at with this is that this histogram tells us how the data is spread out even better than the frequency distribution does. Because when we look at that picture, what part of it draws your attention the quickest? This part out here or this part? Which seems to be more important? Where's more of the data? More of the data is right here, okay? There is still some data up here, but there's very little on this end. This histogram is what we describe as being skewed right, which means as you move to the right, there's fewer and fewer and fewer data values. So the skew follows where the data trails off, not where it peaks. So if it starts out high and then trails off, that's skewed right. That particular set of data is skewed right. You can label the histogram's horizontal scale with class boundaries, class midpoints, or lower class limits. That actually introduces a little bit of error. It's not a big deal, but it does. The horizontal scale for most of the histograms I'm going to want you to use is going to be the class midpoints. Just because one little number is easier to fit on an Excel spreadsheet than a whole bunch of numbers with a hyphen between them. So just for the ability to look at it. It isn't that it's wrong to label by class intervals or class boundaries, but it's probably easier to label your classes simply by their midpoints. The vertical scale on a histogram is always the class frequencies, and you have to determine, do you want to count it by 1, 2, 3, 4, 5, or do you want to count 5, 10, 15, 20? Because it depends on, if you have a category that has 125 data values in it, you don't want to make an x-axis that has to have 125 tick marks on it. So you probably want to scale that one maybe by 5s or 10s or even 25s, okay? And then put little, what are called minor tick marks in between those. But the key is that the histogram's vertical scale goes with the frequencies, the x-axis goes with the categories, okay? Now we're going to actually make this one, but I think we're going to wait until the first of class next time to actually make the histogram. Because I don't think the Old Faithful worksheet has you make a histogram, does it?
No, it doesn't.
Okay, so that's a good practice and wrap up for what we've done today. But I want to go a little bit further with what we're doing and talk about the shapes of distribution since I started with it. This distribution is referred to as bell-shaped. Bell-shaped. Think about a Christmas bell. You know, all those cute little Christmas bells we saw back in December. What they do is they're really tall in the middle, and when you come down their sides, they kind of just flow down the side, but then at the bottom, they kind of turn out. Have a little lip on the bottom. If you hold it upside down, it looks kind of like a tulip or something. The bell idea is that this data set starts low, builds up to a maximum somewhere around the middle, and then goes back down to being low again on the other side. A bell-shaped distribution like this has a lot of important properties that we're going to talk about in Chapter 6. This is also referred to as an approximately normal distribution. Okay? If we had a histogram that looked like this histogram is referred to as a uniform distribution because all of the frequencies for all of the classes is relatively the same. The bars are about the same width. Now this would not be non-uniform if, for example, the first bar was just a little bit taller and the next bar was just a little bit shorter, and then this one's a little bit taller, and this one's a little bit shorter, it's still, we would refer to that as relatively uniform. They don't have to be exactly the same frequency. But if you read down your frequency table and you see 3, 4, 4, 3, 5, 4, 3, okay, that's pretty uniform, somewhere between 3 and 5 for all the categories. And as we talked about a minute ago, this is skewed right because it starts out low but builds quickly to a peak, and then after the peak it kind of trails off. Think of it as a ski slope. You would ski down this to the right. This one, on the other hand, you don't want to ski up, because how hard would it be to ski up that slope? That'd be tough.
What would you do to put on the chairlift on the right side of
You could. So here's what would happen if you were actually skiing here, and that's what you want to think of, is if you're a skier and you're sitting on the top of this bar, which side do you want to ski off of? You want to ski off this side? What's going to happen to you if you fly over this one? I die. What? You'd be splatted. And the same thing here. Do you want to ski off to the left? No, because it'd be like jumping off a cliff. So if you're the skier on the tallest bar, you're going to ski off to the left here, but to the right here. Okay? So think about which way the skier would go. That'll tell you the skew. Skiing and skew is the same thing. This is called a bimodal distribution. We'll talk more about what the word mode means the next class we have. The mode is the highest frequency. This frequency is not exactly equal to that one, but there's two obvious peaks on that histogram. It goes up to a peak and then back down, and then back up to another peak and then back down. And those peaks are referred to as its mode. There are some other statistical graphs which we will get into next time. Right now, all I want you to do is just be aware of them, and we will come back through these. But I just want to skim over the ideas first. There's a frequency polygon, which we will not make. I'll explain to you what it is and what it does, but we will not make one. There is a relative frequency polygon, and the only difference between the two is that the vertical axis represents either frequencies or relative frequencies. I have never, as a professional statistician, and that's what I did before I started teaching, I have never used an ogive for anything because nobody understands it. Okay? Don't worry about it. Don't memorize it. It's in the recording for posterity. I'm not going to ask you what it is on test. We will make dot plots. They are quick down and dirty, easy histograms.
They are very easy.
Stem and leaf plots, same thing. We will talk about stem and leaf plots the next time. And then if you're comparing two data sets like the male and female pulses or the median income for men and women, you might want to make a bar graph where you have the male bars and female bars next to each other so you can compare. And then we will talk about making a Pareto chart. I don't like this one because it is not actually really a Pareto chart. Pareto charts do not join their bars. They should be separated because it's a type of bar graph. And then there's also pie charts. I'm going to let you make one by hand so you understand why you never want to make them by hand. And then we'll end up talking about scatter plots, probably not next class period, but before the test we will talk about scatter plots. Okay? And we will talk about time series graphs. And a little funny for the end of the video, this is a pie chart showing my favorite bars. This is a bar chart showing his favorite pies. Okay? Y'all have a good afternoon and evening. I will see you on Monday.
Do you want us to do Old Faithful and Turning In tonight?
Please do Old Faithful and Turned In tonight. begin working on the chapters two stuff in my math lab and in Shelby. But if you don't get it finished, it's okay, because I know where we are. Don't sweat the due dates until I'll send you a message and say, okay, this is the cutoff, you're done, if you don't have it done by tomorrow night. But right now, chapter 2 stuff is where you should be working.
It's down.